Thank you. Good morning, all, and thank you for the opportunity to present here at the OIS. This is the first time that Precise Bio is presenting. Precise Bio is a company in the field of regenerative medicine. What we essentially are doing is taking regenerative medicine technologies, specifically tissue engineering, and focusing now in the ophthalmology field. Over the years, and I would say the last 20 years, 2 decades, we are seeing technologies that are evolving in the field of regenerative medicine. It's talking about cell technology, scaffolds, biomaterials, and other enabling technologies. Specifically, we are focusing, bringing 3D printing into that field. There are approved approaches, and you can see here on the left side of the slide, a process that was done regenerating from a patient's own cells, regenerating urethra, starting from a tissue biopsy, extracting those cells from the biopsy, then expanding them, and together with scaffolds, building a new tissue. And you can see on the right side of the pane, somebody that was injured in an accident. There was trauma, regenerated his urethra, and then it was transplanted back in the body with 6 to 8 years follow-up, fully functional, autologous solution. So what we are doing now is taking these technologies that have been proved in a manual way that can do several times, but really scaling them up and bringing them to the patients. We are taking 3D printing technologies, a unique printing technology that we have developed in Precise Bio, where we have high resolution, where we can essentially deposit cell by cell and structure the tissue in the same anatomical structure as it is in the body, and building new tissue from the patient's cells. The biofabrication, as we call it, not just the 3D printing, and I will elaborate, we really have a process that is not just 3D printing, but more a 4D biofabrication process where after we do the printing, we have another dimension of time where we mature the technology, we mature the tissue, and this brings us the capability to have a tissue with the integrity as it is, as we find it in the human body. And the biofabrication enables us to scale up, to reproduce it, to repeat the process exactly time after time, get a quality controlled process, and leading also to a cost-efficient solution. The process starts from sourcing of the cells. And any tissue that we have in the body is comprised of cells and ECM and other materials, and this is the first stage. There are indications where it will be autologous. There are indications that will be allogeneic. After we source the cells, we can expand those cells. So, for example, if we're talking about a cornea or endothelial layer, we can take from one donor and expand that up to 70 times the quantity of cells. After the expansion, we take these cells and together with biomaterials that we have developed, we mix them and think of a printer where you have everybody has in their house a RGB, a red, green, and blue. So we have a printer that in each cartridge we have a type of a cell together with another biomaterial. And this leads us to the stage where we are really biofabricating the tissue, where we deposit cell by cell together with the other biomaterials that we have. And this is the fabrication of the tissue. The last stage is the maturing stage, where after we put the cells have to interact with each other. Between the layers, we have to have a good adherence, good connectivity, and functionality. And this is the process that we have defined at the Precise Bio, a 4D biofabrication process, where we look at it as a production where we can bring these tissues to the patients. We are focusing now at the Precise Bio in the ophthalmology field. At the original, when we started out, we have printed cardiac tissue, we have printed liver cells, but our focus now, and these are our first indications, is in the ophthalmology field. And the first 3D printed tissue that was transplanted a year ago, a bit over a year ago, was a DSEK, where we took endothelial cells together with collagen and printed the tissue, transplanted it. And the way we think of it is also that since all the materials are materials that we can control the cell density, as you can see here, we can control the stiffness of the material, we can control the thickness, since it's a 3D printer, and essentially we can control the properties of the tissue that we are preparing to transplant. Recently, and just a few weeks ago, we have started another set of preclinical trials, an ocular surface transplant. In this case, it's also allogeneic biofabricated product. It's a very simple process, and we are in the stage of animal studies. 3D printing and the eye work together. The eye is built from layers. 3D printing, any 3D printing process we do, take a 3D structure, reduce it down to 2D, and build it layer after layer. That's one of the reasons we're focusing in ophthalmology. Just to trigger our imagination, two other indications that we are working on in the R&D, vision correction lenticule, as you can see here in these results that we're presenting, and also a retinal patch, and this is a follow-up that we have of several months already of our RPE layer, and this is just the beginning. This is the first indications that we're working on in the ophthalmology field, and as you all know, we can imagine many, many more indications. Thank you.